SilicoXplore, a deep technology company. We build the engines that find medicines, quantum chemistry, molecular physics, machine learning, software engineering, 4 hard disciplines held inside one company and pointed at a single target. And we do not wrap other people's science. We write our own. Our own docking engine sits right at the core of this company, and around that core, 29 tools, 8 disciplines, and the whole of it inside a browser. And every line of it was built for one reason: so that no good idea is ever lost for the want of a machine, a license, or a line of code. That is the conviction SilicoXplore was built on. The limit on discovery should be your science, never your software. We have named thousands of diseases. We can treat only a fraction of them. Every field of medicine keeps a list it cannot touch, and people are living inside that list. And a new medicine takes 10 to 15 years to arrive. Discovery, preclinical, 3 phases of trials, review, a decade and a half, measured in human lifetimes. 10 candidates enter clinical trials. Around 9 of them will fail, and every one of those failures is years that somebody did not have. But look closely at where that decade actually goes. A great deal of early discovery is not spent doing science at all. It is spent fighting the tools that were supposed to make science possible. 2:47 in the morning, the environment will not solve. Conda conflicts, Qt versions, a compiler error in a library nobody has maintained in 4 years. This is not a hard day. For a computational chemist, this is Tuesday. 1x, Hyan, Pandas, Durm, Hyuda. 5 skills standing between a scientist and the question they actually wanted to ask, and not one of them is chemistry. And while the environment refuses to build, the molecule sits there, unexamined. A question that could have been answered in an afternoon is not answered at all. So we asked one question: what if none of that friction existed at all? SilicoXplore, from SilicoXplore. 1 platform, 29 tools, the complete drug discovery cycle, inside your browser. It lives in the cloud, nothing to install, nothing to configure, and not one line of Python. You open a browser and every tool is already running. And this is the whole of drug discovery: structure-based and ligand-based, target, design, screening, docking, dynamics, safety, and back around again. Every stage of that loop lives in one place. Most platforms pick a side: the AI camp, fast, learned; the physics camp, rigorous, unforgiving. SilicoXplore refuses to choose. Prediction, checked by physics. Physics, accelerated by AI. 29 tools, 8 disciplines. Some we built ourselves. Some are best-in-class engines we integrated and made usable. What matters is that they all speak to each other and that every result comes back interpreted. It begins with the target. Protein modeling folds it. Pocket Finder maps every cavity on its surface and scores the one worth attacking. Mutation Inducer asks how the target will fight back. What happens when it mutates and the drug stops working? FarmFrag builds the pharmacophore. Dotors, acceptors, hydrophobic contacts, aromatic rings, the exact shape and chemistry a molecule needs in order to bind at all. The Novo generator draws molecules that have never existed, grown atom by atom, to fit that site. Silico screen takes millions of compounds and hands back a shortlist. And then, the docking, thousands of poses sampled inside the site, hydrogen bonds, hydrophobic contacts, electrostatics. 1 pose survives. So here is where we planted our flag. SilicoDoc is ours. The pose search is ours. The scoring function is ours, engineered from the ground up, on a machine learning core, not a wrapper, not a fork. And the answer comes back with its reasons attached. QSAR predicts potency before anyone has touched a bench. Then the physics. Molecular dynamics runs 100 nanoseconds of real atomic motion. The question is simple: does the bond actually hold? And where the force fields run out of road, DFT takes over. Quantum chemistry, orbital, bit orbital. Finally, PharmK AI and Tox AI ask the question that kills most drugs: what will this molecule do inside a body? Asked in week 1, not in year 8. And you will never write a line of Python or open a terminal. A chemist gets to spend the day being a chemist. And here is the part we are proudest of. You do not need to be a programmer to use artificial intelligence. Medicinal chemists, pharmacologists, biochemists, chemists, biologists, biotechnologists. AI-driven drug discovery is not a specialist's privilege anymore. It is for all of us. If you know your science, the interface will meet you where you are. You point, you click, and you read the answer in plain language. 10 molecules, or 10 million, the same few clicks. The cloud does the growing, not you. Licensing bends to you, weeks or years, one seat or an entire team. And your chemistry stays yours, encrypted, isolated, and never used as training data. And you do not have to take our word for a single thing we have just told you. For papers published this year in Nature Portfolio's scientific reports, in 2 Elsevier journals, and in the International Journal of Molecular Sciences, tuberculosis, cancer twice, invasive fungal infection, 4 targets, 4 teams, and every one of those studies was run on SilicoXplore. One of them has our name in the title. So SilicoXplore is not a demo, it is finished work, ready to carry a program all the way to a high-quality publication, ready for a patent filing, because the molecules it designs have never existed before, and ready for the decision that actually matters, choosing the handful of molecules worth the cost of a preclinical program and everything that comes after it. We cannot make discovery easy, but we can make sure that the hard part is the science and nothing else. A university group in Nairobi, a 2-person biotech in Boston, a laboratory in Bangalore, the same 29 tools, the same afternoon. SilicoXplore from SilicoSensia, drug discovery, for everyone with a question worth asking. Write to us, hr@silicosensia.com.